Welcome to the second session of this circular function series. In this session, we will further explore symmetrical properties, compound angle formula, features of circular function curve along with quadratic and composite function. We will demonstrate 12 worked examples.
Hello, math champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to the second session of the circular function series. Here, example 1 is to solve an equation of tangent squared x plus 1 minus square root 3, or in parentheses, times tangent x equals square root 3. Given that x is between 0 and 2 pi, both endpoints are inclusive. Since the equation can be reduced to its quadratic form, it is factorized to tangent x minus square root 3, or in parentheses, times tangent x plus 1, or in parentheses equals 0. So, when tangent x minus square root 3 equals 0, the general solution can be expressed to x equals n pi plus pi over 3, where n is an integer. Hence, x equals pi over 3 or 4 pi over 3. When tangent x plus 1 equals 0, the general solution is expressed to x equals n pi minus pi over 4, where n is an integer. So x equals 3 pi over 4 or 7 pi over 4. In conclusion, x equals pi over 3, 4 pi over 3, 3 pi over 4, or 7 pi over 4. In example 2, what we are given is that fx equals tangent x, while gx equals 2 times x plus pi over 2, or in parentheses. There are two questions in this example. The first question is to find the exact value of f of g pi over 3. And the second question is to solve the equation f of g pi over 3 equals negative 1, given that x is between 0 and 2 pi, including both endpoints. Since f of gx equals tangent gx, which equals tangent 2x after being simplified, therefore f of g pi over 3 equals tangent 2 pi over 3, which equals negative square root 3. Since f of gx equals tangent 2x, which equals negative 1, x equals n pi over 2 minus pi over 8, where n is an integer. Hence, x equals 3 pi over 8, 7 pi over 8, 11 pi over 8, or 15 pi over 8. Example 3 is to prove 5 trigonometric relations. As for the first relation, we may recall the sine addition formula, as shown in red color on the screen. So the left-hand side of the expression now can be simplified to 2 times sine 4 theta plus theta, which equals 2 times sine 5 theta, which is exactly the expression on the right-hand side. As for the second relation, the left-hand side can be written to cosine 2 theta plus theta, and then expanded according to the cosine addition as well as cosine double angle formula. After being expanded, the cosine double angle formula is applied here. So cosine 2 theta is replaced by 2 times cosine squared theta minus 1. Sine squared theta is replaced by 1 minus cosine squared theta. Hence, cosine 3 theta equals 4 times cosine cubed theta minus 3 times cosine theta.
Here we continue to work on example 3. As for the third relation, we expand the complete square on the left-hand side first. Then after combining and simplifying all the terms, we find it equals 1, which matches the number on the right-hand side. As for the next relation, since 1 over sine squared theta plus 1 over cosine squared theta can be transformed by combining them into one fraction, and then we find it equals 4 times cosecant squared 2 theta, which is exactly the expression on the right hand side. As for the last relation, it can be seen that the expression on the left hand side can be transformed to 1 minus sine raised to the 4th theta or over cosine raised to the 4th theta. After factorizing the numerator and then simplifying by cancelling the cosine squared theta with the denominator, it equals 1 plus sine squared theta or over cosine squared theta as required.
In example 4, sine theta equals the ratio of 2m minus 3 or over 4 minus m, given that the angle theta is in the third or fourth quadrant. The question is to find the value range of the real number m. Since the angle theta is in the third or fourth quadrant, sine theta is less than 0. So the expression of 2m minus 3 or over 4 minus m is less than 0. Hence, two sets of simultaneous inequalities are established to find the value range of m. After solving the two simultaneous inequalities, we obtained the value range of m, which is either greater than 4 or less than 3 over 2. Example 5 is a multiple choice question, and it asks to compare the value of sine squared theta, cosine squared theta, and cotangent squared theta, given that theta is between 0 and pi over 4. Since theta is between 0 and pi over 4, then all the three circular functions, sine theta, cosine theta, and cotangent theta, are greater than 0. Within the given domain, sine theta is less than cosine theta, which is less than 1, which is less than cotangent theta. Hence, sine squared theta is less than cosine squared theta, which is less than cotangent squared theta. So the correct statement is number 3.
Example 6 shows that fx over 2 equals tangent x. The question is to evaluate f31 pi over 6. Since fx over 2 equals tangent x, then f31 pi over 6 equals tangent 10 pi plus pi over 3 after being simplified, which equals tangent pi over 3. So f31 pi over 6 equals square root 3. The given criteria in example 7 are tangent theta equals x over x minus 1 and tangent phi equals 1 minus 1 over x. The question is to evaluate theta plus phi. Let's recall the addition formula for tangent function. Since tangent theta plus phi equals the ratio of tangent theta plus tangent phi, or to the result of 1 minus tangent theta times tangent phi. After substituting tangent theta and tangent phi by their expression in terms of x accordingly, we find the value of 1 minus tangent theta times tangent phi equals 0. Hence, theta plus phi equals n pi plus pi over 2, where n is an integer. Example 8 is to evaluate a trigonometry expression of sine 20 degrees, cosine 10 degrees, minus cosine 160 degrees, sine 10 degrees. According to the expression, we may apply the supplementary relation to transform the second quadrant angle 160 degrees to the corresponding first quadrant angle. So the expression equals sine 20 degrees cosine 10 degrees minus cosine 180 degrees minus 20 degrees times sine 10 degrees, which equals sine 20 degrees cosine 10 degrees plus cosine 20 degrees times sine 10 degrees. After applying the addition formula, it equals sine 30 degrees, which is 1 over 2. Example 9 is to evaluate a trigonometry expression with cosine and tangent functions. After careful observation, we may transform the term on the numerator and then apply the addition formula to simplify the expression. So after expanding the numerator and then multiplies and divided by 2, we may see the numerator is in the form that can be simplified using the addition formula. Meanwhile, the denominator cosine 50 degrees can be transformed to sine 40 degrees according to the complementary relation between sine and cosine functions. So the original expression equals 2 times sine 30 degrees plus 10 degrees divided by sine 40 degrees, which equals 2. Example 10 is to evaluate an expression with trigonometry functions. It contains sine and cosine functions. Similar to the previous example, the numerator is transformed by applying the addition formula, while at the denominator, sine 10 degrees is transformed to cosine 80 degrees, which is expressed to 1 minus 2 times sine squared 40 degrees. Hence, the original expression can be simplified to 2 times sine 40 degrees over the product of square root 2 and sine 40 degrees, which equals square root 2. Example 11 is to simplify an expression with trigonometry sine and tangent functions. After careful observation, we substitute square root 3 by tangent 60 degrees. The next step is to transform 1 plus tangent 60 degrees, tangent 10 degrees to the ratio of the product of sine 60 degrees and sine 10 degrees to the product of cosine 60 degrees and cosine 10 degrees, which equals cosine 60 degrees cosine 10 degrees plus sine 60 degrees sine 10 degrees, or over the product of cosine 60 degrees and cosine 10 degrees. Then we apply the addition formula here to simplify the numerator, which equals cosine 60 minus 10 degrees. So the original expression equals 2 times sine 50 degrees times cosine 50 degrees divided by cosine 10 degrees, which is further simplified using double angle formula as well as complementary relation of sine and cosine functions. So 2 times sine 50 degrees cosine 50 degrees equals sine 100 degrees, which equals cosine 10 degrees. Hence, the original expression equals 1. Example 12 provides a cosine function with parameters a, n, and epsilon. The function has a period of 4 pi and a range between -5 and 5. Both endpoints are inclusive. It is also given that when x equals 0, the function equals 5 square root 3 over 2. According to the given range of the function, a equals 5 minus -5 over 2, which equals 5. Since it has a period of 4 pi, 2 pi over n equals 4 pi. So n equals half. Since the function equals 5 square root 3 over 2 when x equals 0, we have the equation 5 times cosine epsilon over 2 equals 5 square root 3 over 2. Hence, cosine epsilon over 2 equals square root 3 over 2. Hence, we calculate the value of epsilon by using the arc cosine square root 3 over 2, which is pi over 6. So epsilon equals pi over 3. In summary, a equals 5, n equals 1 over 2, and epsilon equals pi over 3. If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.